Hey everyone, my name is Nadine and I'm super excited to be here today. I'll be talking about how to make developers who build all sorts of applications be more productive with real-time analytics as an API. But before I go into this, let me give a quick intro about myself. Largely, my background has been focused on connected products, so iOS development, Bluetooth, hardware, and databases. And before transitioning into developer advocacy, I was an engineer in these areas. I've been at Rockset for about 10 months, largely focused on helping developers build real-time analytics at cloud scale. So this is a great segue to quickly talk about Rockset. Rockset is a real-time indexing database built on the cloud, empowering application developers to easily access and use data without too much friction or high ops. And Rockset is a hot layer on top of your primary database to do more of the heavy lifting to get real-time data. And so it incorporates a couple of developer-friendly features that allow you to use any data type like JSON, XML, and so on, and turn it into SQL tables pretty seamlessly. You can get high query performance because Rockset automatically indexes the data for you in 3 different ways called converged index. And so basically, converged index means all fields in the document are indexed via row index, columnar index, and an inverted index. Rockset illuminates the need for managing servers and clusters because it's completely serverless. And finally, you can turn SQL queries into real-time analytical APIs that you can embed in your application. This part is the main focus of our tech talk, but before we dive into this, let's take a look at the agenda. The first half of the talk is going to go over how you can build real-time analytical APIs with ORMs, Elasticsearch, and Rockset Query Lambda. The second half of the talk will be devoted on showing you how you can build real-time analytics with Rockset and Postman. And don't worry if like ORMs or object relational mappings, Elasticsearch, and Rockset Query Lambda are completely foreign. I'll go over the terminology and concepts when we get into these sections. So even though we'll be talking about how to build real-time analytical APIs, it'll be good to know how they are used. So real-time analytical applications like leaderboards and interactive SaaS dashboards are built using real-time analytical APIs that join, aggregate, and search in real time with high performance. So for example, a fraud detection application needs to alert the business when someone's committing fraud within milliseconds, not minutes, because anything greater than a sub-second latency can result in a business losing hundreds of thousands to millions of dollars. But how do you go about building such application? Let's see what this workflow looks like. When we think about building real-time analytics like personalization and fraud detection, just as I've mentioned it in the previous slide, it can be broken down into 3 major categories that are kind of common best practices. So the first one is you send data to your primary database, and this is your normal transactional workload on the database that's a source of truth. The second is you'll offload real-time analytics to a data store. And then finally, you'll create APIs to fetch data from the data store. Now, within these major categories, there are certain parts we care about and other parts that we depend on different engineers to create and maintain in order for us, application developers, to be productive. I'm going to paint what this landscape looks like, and from there, I'll dive into real-time analytical APIs. So at the bottom, I've given some examples of databases and data stores that developers usually implement to do real-time analytics. I've kept it general in my walkthrough, but keep in mind any one of these databases or data stores can be substituted here. So the first category I mentioned is sending data to your primary database. You may have multiple sources where data is being sent to your database of choice. So if you're using a relational database like Postgres, a data engineer may need to pre-process the data. And if you're using a NoSQL database like MongoDB or DynamoDB, you store data as it is. And the second is when offloading real-time analytics, you'll want to offload it to a data store. So usually when you're building real-time analytics, you'll want your primary database to have a different set of features than your analytical data store. And usually a data engineer will do an ETL where they'll load data from the primary database to a data store. And typically, you wouldn't want your primary database to do analytics because analytical queries can be CPU intensive and block or delay the execution of other queries. And when writing real-time analytical APIs, we'll want to use joins, aggregations, and search, but how we write them will be vastly different. So in this slide, there are two takeaways that I want you to remember. One, real-time analytics, you need a separate primary database and data store. And two, you want to build APIs that are easy to use so people who don't know about databases or SQL structures can easily consume and access the real-time analytical outputs of the APIs. So now we have a high-level understanding of how real-time analytical applications like personalization and fraud detection are built. But let's see how we can create real-time analytical APIs with ORMs to get real-time insights. At a high level, an ORM, or object relational mapping, is the process of mapping between objects and relational database systems. It's used to persist your objects to a relational database. So you write queries using your object-oriented paradigm of your language, for example, Python or Java and so on. And from there, the ORM writes a SQL request for you. So one of the benefits of using an ORM is you can write application code for basic CRUD operations, pretty fast without worrying too much about what the database or the SQL. So let's say we're building a personalization app where we want to advertise based on the user's city location. On the top here, we have a simplified SQL query, but nonetheless, it's still doing a join over here. And on the bottom, we have the same query written in Python syntax using Django. Django has an ORM, which is what this example is based on. But it's important to note there are many different types of ORMs that can be written in many other languages other than Python. So if we wanted to create an API that executes this query, it can look something like this. You can see the Python syntax allows us to iterate faster on an app. And we don't have to worry about writing SQL. The code looks super simple compared to what we've written before. But this simplicity can work against you if you're unfamiliar with how this code is working behind the scenes. So keep in mind, every ORM will be somewhat different in how it operates. So here, Django's select related over here that I'm highlighting does a join in the database call and caches the related object in a hidden attribute of U2, which is over here. And this is great because we don't have to query the database again when we want to see where U2 resides in, which is over here. So at the bottom, we're actually using the cache data to get U2 city's location. And in terms of performance, this is great because we save on an extra read on the database. But if we were to create an API this way, we would query the database 2 times. We query the database once to get the user with ID 2 over here, and we query it again when we want to see where U2 resides in over here. And the point here is nothing is getting cached like it was in the previous API. So if we were scaling this for real-time analytics, we can accidentally stress the database, impacting performance. So the point between these two slides is how you write your API matters because it can impact performance when it comes to scaling. So to wrap up ORMs are great when you're getting started in an app that needs structured and relational data. But some of the considerations with real-time analytics now is an ORM can hide how many reads are happening behind the scenes, which can stress the database. And if there's a performance decline, it won't be obvious where it's coming from or why. And performance matters in real-time analytics. And many ORMs do offer the ability to cache data, trading off speed for memory and consistency. But this can come with spikes to RAM usage. So you have to be aware when an object is being cached and see if this is the intended behavior you wanted. If you end up caching a lot of data, you can use up all your resources and get an OOM or out of memory error. So the TLDR here is every analytical query you write when using an ORM, make sure you know how it's working behind the scenes and its impact on speed, memory, and scale. But let's say, we're writing an analytical query, but we're having trouble writing it in Python. Many ORMs do offer the ability to use raw SQL instead, something like what's shown in this gray box on the left over here. But one of the considerations we have to ensure is that the query is SQL injection free. Using string interpolation in your queries, something like here, gives a bad actor opportunity to make your database vulnerable. So you have to be extra vigilant that you're not making these types of mistakes. So now that we talked about writing real-time analytical APIs with ORMs, let's switch gears and talk about writing real-time search APIs with Elasticsearch. So Elasticsearch is a NoSQL database that is optimized for real-time search functionality. For example, if you need to do like a log search or a product name search, Elasticsearch is a great tool to use. And the reason it's so popular for search is because of how it indexes data is so efficient for it. And in this picture, I'm showing an example of what a log search can look like. But let's say we are building an online marketplace where we need to search the products, right? We'll need to build a search API that calls Elasticsearch on our behalf. As you can see, we have the API endpoint search over here that when called with the parameters, Q equals some search term, it can perform a match request to Elasticsearch. And here we are asking Elasticsearch to look for a search term with either the product title or description over here using the should keyword, which is over here. And the way this API is written, it's great, right? It's easy to manage, it's easy to test, and it's super clean. But if we need to join multiple documents in Elasticsearch, you'll have to write more application code and logic. And so here we have a SQL query where we are joining two tables or collections called purchases and ratings. And so if you want to write something similar to this query on Elasticsearch, it looks something like this. And so as you can see, the server-side code complexity is high, and it only becomes more complex as you add more stats and introduce large results sets that require pagination. And the join at the bottom here has to fetch these two data sets to the application's process memory and then do the joins. Where if you do it in a SQL database, the database does the joins and returns the results that matches the query. And the advantages with using a database is you can save on resources. So SQL joins not only make your application code lightweight, but also save on resources. So Elasticsearch is great for text and log search and on semi-structured and less structured data. But although Elasticsearch has been the default data store for search for a very long time, it lacks the SQL-like join support that makes building rather some trivial applications slightly more challenging. You may have to manage joins natively within your application, meaning more code to write, test, and maintain. An alternative solution may be to normalize your data when writing to Elasticsearch, but that also comes with its own challenges. So as a result, it requires additional engineering work or engineering overhead to write more code to flatten the data store in multiple relational tables and map it to a single object in Elasticsearch. So now that we talked about building real-time applications and real-time analytical APIs with using ORMs and Elasticsearch, let's see what this workflow looks like in Rockset. So like before, you'll load data normally to your primary database. But now, if you wanted to power real-time analytics, you don't need a data engineer to do an ETL and such, which is a very expensive process and creates a lot of lag. As an application developer, you can provide read permissions to Rockset. And from there, Rockset directly reads and stores the data coming from the primary database like DynamoDB. And after the data is in a collection in Rockset, you can directly query the data using SQL. After you write your SQL query, you can turn it into API endpoints on Rockset that you can just embed in your applications to get real-time insights. So before we talk about the APIs Let's see what the queries look like in Rockset. As just mentioned, you'll write your queries after the data has loaded in Rockset. And so on the left, we have the same analytical query that I've shown in ORMs and Elasticsearch. And on the right, you have what it looks like in Rockset. And as you see, the SQL is exactly the same. But really, what does the API look like when you're writing it in an app? So once we write the query in Rockset, we can turn it into an API using a Rockset query lambda. So query lambdas are named parameterized SQL queries stored in Rockset that can be executed from a dedicated RESTful endpoint. Using query lambdas, you can save your SQL queries as separate resources in Rockset and manage them successfully through development and production. So this is the query lambda, and this is what it looks. And if you notice, we don't have to write any SQL in our app. And this greatly simplifies the application code logic, and it's so much easier to maintain and test. And in the case with this API, we'll be able to have millisecond query performance because of how Rockset indexes the data. So as a quick recap, Rockset uses converge index, which indexes all data via a row index, a columnar index, and an inverted index. And depending on the query, Rockset chooses the best index to give you sub-second query latency. So now to come full circle, real-time applications like an online marketplace and fraud detection, and so on, execute real-time APIs like what's shown here to get insights within seconds to make critical decisions. So even though Rockset uses SQL, it is able to ingest any semi-structured or structured data without needing to define a schema. And under the hood, Rockset infers the schema. Rockset separates compute from storage, and its compute is cost efficient for up to terabytes of data. And Rockset is cloud-only analytics, so it's not meant to be a transactional database or a permanent data store. And Rockset is not suited for companies that need on-prem. So at Rockset, we saw a lot of users experience some challenges when building real-time analytics. Usually, expertise was split between a data team and an application development team. And in this workflow, it's hard for these two teams to collaborate safely. For example, a developer can actually tweak a SQL query and introduce an order by clause and accidentally have a 10x slowdown in performance in the application without ever realizing it. And also getting optimal performance and maintaining server-side code for the API can be challenging depending on what data store they're using and how you're optimizing for it. So we set out to build a developer API platform for real-time analytics that's easier and faster. So in the case of collaboration, developers and teams can share the API endpoints with each other and see the different versions of the queries, if the query is tagged for prod or staging and so on. You can think of it as like GitHub, but for like analytical queries. And finally, developers can get millisecond query performance, without writing extensive server-side code. So this wraps up the first section of the talk. So let's dive into the demo. Building real-time analytical applications can be done in just a few steps. And I've kind of shown what these steps are, but we'll go ahead and quickly recap here. You'll give Rockset read permissions to your primary database, right? And the data will be stored in a Rockset collection, which is in step 2. Afterwards, you'll write your SQL query and create an API endpoint, which is step 3. And then finally, you'll embed your endpoint in your application to get real-time insights. And in this case, we'll be using Postman, where we'll check the response back. So now let's go ahead and see this in practice. After you've logged into Rockset, you'll want to create an integration to your primary database. So Rockset can get read permission to read the data coming in. And here we'll be using DynamoDB. But of course, you can use any of these data connectors listed here. And if a source doesn't exist, you can use the right API to write directly to a Rockset collection. So I'm going to go ahead and click on the DynamoDB data connector, which is here. And I'm going to go ahead and click on Create Integration, assuming that we don't have an integration created. So the instructions here give you step-by-step on how to configure your AWS IAM policy so Rockset can get read access. And at the bottom, you'll give Rockset the role ARN, which is listed over here. And this is it. And this actually comes from AWS. And this is how Rockset gets read permissions. But every source or data connector or every integration that you build will have different sorts of instructions on how you give Rockset read permissions. So just make sure you follow the instructions. So I already have an integration created to speed up the demo. So let's go ahead and click on this integration and click Start. And I'm going to go ahead and give this collection a name. Okay, and I'm going to give it a description, which I have here. And so now the Dynamo table name actually comes from the table you created in AWS. Here, I created a table name called Northwind, and the region I'm using is US West 2. So you'll see that the data is automatically loaded to Rockset with actually no schema definition, also known as schemaless ingest. So even though Rockset uses SQL to write analytical queries, it can accept semi-structured data. And under the hood, Rockset infers the schema, as you see here. So now let's go ahead and create the collection. So the data that's coming in is now being stored in a collection. So I'm going to go ahead and create it. So as we create the collection, Rockset indexes the data via converge index, which does row, columnar, and a search index on all fields in the document. I've already created a collection for the purposes of this demo, so I'm going to go ahead and click on the collection I've created. But once your collection is created, let's see, this is it. Once your collection is created, you'll see all the available fields over here. And this is the fields that you'll use to construct your SQL queries. And you'll see the data over here as well in the documents. So I'm going to go ahead and we're going to go ahead and query this collection, which brings us to the query editor. You'll see that the query editor already has a SQL query pre-populated. But what we're really interested in is analytical queries that can join, aggregate, and search. So I'm going to go ahead and copy an analytical query that I already have. And I'm going to delete this pre-populated SQL query. And I'm just going to format it really quick and run it. And so I won't go into too much detail over here with what this query is doing. But I will point out some of the main highlights that we've been talking about. You can join, and you can also do aggregations as well. And if you see, this query returned in around 71 milliseconds. But the idea here is that if you have terabytes of data and you're writing, a monstrous analytical query like this, the response should come back within hundreds of milliseconds. So from here, we can create an API that will wrap this analytical query. So I'm going to go ahead and create a query lambda. And I'm going to go ahead and give my query lambda a name. And I'm going to give it a description. And I'm going to go ahead and create this query lambda. So there we go. And so you see that when we create this query lambda, you'll be able to get the versions listed, which is over here. So as you iterate through this query and you update the SQL, you'll be able to create versions. You can also see the underlying SQL as well. And you also see some other metadata here. And if you wanted to tag this query for, prod or staging and so on, you can do that as well over here. So if I scroll to the bottom, I'll be able to get the API endpoint, which is here. But at the bottom here as well, you can see the various code snippets that you can embed in your application as well. I know that my API keys are shown here, so I'm going to invalidate them right after this tech talk. But in our case, what we really want to do is we want to copy this API, which is wrapping our analytical query, and we're going to actually go ahead and paste it in Postman. And I'm going to go ahead and send this data. And as you see over here, we get our response back. And so now once you get the response, you can do whatever you want with this data. And if you wanted to monitor it and see how, your overall health metrics, you can do that over here as well with Postman. So this wraps up my tech talk on being a more productive dev with real-time analytics as an API. Definitely check out our docs at docs.rockset.com. And if you enjoyed the talk, feel free to give me a shout out or Rockset on Twitter. And I'm happy to take any questions now. See. Let me, so this is the, so let's going back to Postman. I copied the API endpoint from the console over here, and this API endpoint wraps our analytical SQL query, which is, if we go back over here, this is a SQL query that I've written in the query editor. And so in this summary, when we go to the bottom, we get this API endpoint, and on Postman, you can just make a post request over here, and then you click send, and then you'll be able to get the response back. So now you're seeing the results of the analytical query over here. Does this help answer your question, Aaron Hicks? So we have another question. So does Rockset allow for real-time queries to be made by consumers on the fly, or are these set queries that you need a new endpoint for each different query? Oh, okay. So can you elaborate more, Jonathan, on what you're and what you mean? So these are so basically what happens is okay, sure, no problem. So Aaron, so does the Postman visualize feature give us anything? I think as you make the request, you can see the overall health and like the response times and such. So depending on how you have Postman set up, you can see how things are performing over time. Does that help answer your question, Aaron Hicks? Okay, cool. So, Jonathan, really quickly, every query that you create on Rockset, it's a different query. You'll have a new endpoint. But if you want to update an API endpoint, you can create versions on Rockset, and each version is tagged with a hash. So then you can see the hashes and iterate as possible. And if you want to use one endpoint for prod or staging, you can do that. Yeah, so basically what happens is when you're building real-time applications like fraud detections and stuff, you embed the API, you actually embed the API endpoint in your application that I shown in a previous slide. And then from there, when your application is running, your API gets executed and then you get the data. So no, this is more developer focused. So consumers, our consumers are developers. So I'm not sure what you mean by consumers, but yes, developers who are Rockset's consumers in particular can create their own queries and create real-time APIs. But if you're talking about like your end user of your product, the whole point is to abstract from this. This is really for a developer facing, developers building application, very much more developer facing. Does that help answer your question, Jonathan? Okay, great. I'm happy to take any other questions. Yeah, so Jonathan says, I was thinking through this from consumers being integration partners and vendors from our core system, so that's helpful. Yeah, so if you're a developer and you're building these like fraud detection, leaderboards, A/B testing, and so on, and you need real-time insights, where you need the insights within milliseconds. This is the ideal use case for Rockset for developers who are building these types of applications. Okay, great, perfect. So I think we're coming close to time. It's almost noon. So I'm not sure. I'm happy to take last minute questions. All right, thanks everyone. And thanks for attending my Tech Talk. And again, if you love the Tech Talk, feel free to give us a shout out at Rockset Cloud. And feel free to ping me if you have any other questions. And thank you for attending my session. All right, have a great one, everyone. Bye.